Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Fareez. Azhad. I am from Group 3. In this video presentation, I'll be presenting about the climate action, which is part of the mini project for the subject ECE431. Let's dive into it. Flooding is one of the most devastating natural disasters, impacting millions of people globally every year, especially in Malaysia. It disrupts daily life, damages critical infrastructure, and causes immense economic losses. With rapid urbanization and the worsening effect of climate change, frequency and severity of the flood are increasing. This alarming trend underscores the urgent need of reliable tools to predict and mitigate flood risk effectively. The flood risk assessment tool is designed to address this ongoing challenge by analyzing key factors such as the rainfall intensity, river water level, and population size. The tool provides a comprehensive assessment of flood risk. It offers practical recommendations that enable individuals, planners, and authorities to make timely decisions, ultimately helping to protect life and reduce damages. The primary objective of the flood risk assessment tool is to provide users with straightforward yet effective way to analyze flood risk. By processing the data like rainfall intensity, river water level, and population size, the tool classifies risk into 3 levels: low, medium, and high. This categorization helps users grasp the urgency of the situation and prioritize action accordingly. This project bridges theoretical knowledge and practical application. Importantly, it demonstrates programming concepts like control structures while handling and modular design while tackling a critical real-world problem. Next. For the methodology, the program begins by presenting users with a main menu offering several options tailored to their needs. Option 1. The user can upload data by specifying a file name. The program then reads this data and store it in a memory and display an easy-to-read table. Option 2. User can manually input data, including details such as the station name, district rainfall, the intensity, the river level, and population. After that, the input user can choose to add more data or review the stored information in the table format. Option 3. This option will reset all stored data, allowing user to start afresh. For the fourth option, this option evaluates the uploaded or entered data to assess flood risk. The categorize the risk into 4 levels. First, urgent action, the high risk affecting large population. High risk, data exceeding threshold. Third, medium risk, data in moderate range. And fourth, low risk, data below threshold. Results are presented in an easy to understand format to ensure clarity. Last but not least, option 5 and 6. These focus on detailed analysis by calculating statistics related to rainfall, river level, and population. These sites are summarized to help users interpret the data more effectively. And if at any point user can return to the main menu to perform additional tasks or choose to end the session. This logical flow ensures the tool is both user-friendly and efficient.
Now I'm going to demonstrate the program for this mini project. So this is the CSV file that we use to store the data that we collected from the internet, and we store it here in Excel files. So to begin, we first build the project, and this is our main menu for this program. We have several different choices between what to say. The first one is entry from CSV file, which is we took the data from the CSV file from before, and we read it to store it inside this program. And the second one is to input the data manually from this console, which I will show you later. The third is to reset entry. This is to reset all the data that we have been stored inside this data entries count. And number 4 is risk assessment tool, which is to show which of the station and district have the highest chance to be flooding level. Depends on the population. Number 5 is to show the average, the highest and the lowest of the rainfall intensity, the river level, and the population between each district. And number 6 is to quit the program. So to begin this program, first I'm going to type number 1, and then we the input from the user to input the CSV file name. In this case, the file we have been used is data.csv. So we put data.csv, and then we could access all the information from this file. It show all the station, the districts, and the information about its rainfall sensitivity, the available, and especially the population between the respective place. And then to continue, we press any keys, and then they show the data country. The data entries count is 15. This means that there's 15 different station and data that we stored inside this program. So to access the information, if we press 4, it shows us all the flood, all the risks, the place that which the highest chance of flooding depends on its rainfall and river level and population. If it is a dense population and high river level and rainfall intensity, immediate action needs for the solution. If it's a place with low rainfall and river level, we will go around this high risk area, and then in this case the data have none for medium risk area, and the lowest is Bukit Tekong at more. And then we press any keys, and then we access the data analysis. So this is all the data analysis for each station. It shows the highest, the median, the lowest, and also the average for each station. For example, the highest rainfall activities is at Kampung Jenok. However, the lowest is at Sampi. It also shows for river level analysis and also the populations. And then we press and continue. So now there's 15 different data that have been stored. If we press 3, the data has been cleared and reset. And then we press any key and it shows 0, meaning there is no data. So if we press 4, it happens nothing. If we press, it happens nothing because there is no data from this program. Now we have to this program can also enter the information data manually by pressing 2. So for example, if we name our station Selangor, and then this district at Kuala Selangor, and then if the rain intensity is, for example, 15, the water level is 60, and then the rough population is 15,000. So now the data entry count is 1, and we could add another data by pressing Y, and we could stop. So if we press Y, now we also allow us to add another information into the program. So the rainfall intensity now is put 10, the river level is 50, and the population is put 3,000. Now the data entry count is 2. So if we press N, it will allow us to stop any information. Now it shows us all the information that I have been put before. It shows the district, the rainfall, the river level input, and the population. Now we press on continue. We back to the our command prompt, and then we press again like before. 4 it shows us what is the high intensity in a high level chance of flooding. Now in this case I put before, it is Seri Pistana at Kuala Selangor, and Sarjana at Gombak is high risk area. We could also find the data analysis based on the information I have put earlier. So the highest is Seri Pistana, the median is 10, and the lowest is Sarjana, and so on and so on. And if we press 6, we'll quit the program. That's all for me.
Thank you. Now we will discuss about the coding I have written in the Sea Lion software about the risk assessment tool developed by me, Fareez, and Azhad. This is the header file that we will use. Is the IO stream, F-stream, IO manipulation for the output manipulation, vector for the vector usage algorithm for the STD vector, and conio for the getChar function. This is the key escape code for the colors, red, green, and the background also. And we're using namespace std here, and we create a struct named location that have contained a member of string station, string district, double rainfall, double river level, integer population. Initialize the vector of locations, threshold value of the reassessment. The low rain is 10, the high rain is 50, the low river is 2, the high river is 5, the threshold population is 5,000. Integer count is for the unnamed district and station. Function prototype, entries from the file, entries from the console, entries from reset. Risk assessment tools that's passed by reference of vector location. Data access passed by value of vector location. Void display menu is for display menu. Clear the system and printing this and outputting the data entries that we have. In the main, we creating the boolean of is running. While it's running, we will display the menu and getting the user input. If user select one, that is inserting this CSV file and the entries is still empty, we cannot enter it because it will conflict. Next, if the selection is 4 or 5, that means we perform the data analysis, but there is no entries, it comes to an error. So we continue. And if the set is certified, we can do the switch statement here of the select. Case 1 will form the entry for file, case 2, case 3, case 4, case 5, and case 6. Case 6 we will end the program. And here we will read the CSV file, contain a parameter of file name and the pass by reference of vector locations. Input the file, check the file is error, skip the CSV, read by line, input the CSV data into the struct, station, district, rainfall, river level, and population, push it to the vector, and close the file. Printing the table with the parameter or pass by reference of vector location, printing it, entry from the files, input using the standard input, get the file name, using the function CSV, printing the table, wait for user, entry from console, and let's look for manual insertion, initialize the location, insert the station, district. If the station or district is empty, we can place a placeholder here, inserting the rainfall, river level, population, push the data, and if user want to continue adding the data, look endlessly. If the user don't want, exit it, and counter +1 if they don't. Clear it, printing the table, wait for the user to and to reset, clear the console, clear the vector, wait for user reassessment, clear the console, initial vector location of low risk, medium, high urgent action. Look for the location here, check if the location is low risk, push to the vector low risk, check the medium, push to medium risk, check the priority, push the urgent, if not, push the high risk. If empty, push nothing into it, and we're printing it for the user to see. This is the urgent, this is high, this is medium, this is low, and wait for user to enter any key, clear the console, check the maximum index, check the median index, calculate the average, look through the data, member, rainfall, river, and population, divide by the size of the vector, and we will be using a std sort algorithm in algorithm header, using into sort algorithm for sorting. Worst case is O and log n. Time complexity does not take a long time to process large data set. Performing the sorting rainfall, using the sort function, taking the first index and the last index and compare it using the lambda function of first struct and the second struct compared to the rainfall A and rainfall B. Printing it, the highest, the median and lowest and average. Continue for the river level and the population and wait for the user to enter it. That's all for the coding. And for the CSV file, we use this format, the station, district, rainfall, river level and population. Because this is a text file, it's look like this. And if we can make the table, it's like this. It's more prettier to see from this. That's all from me. Thank you.
For the conclusion, in conclusion, the flood risk assessment tool lays a strong foundation for the effective flood risk management. Its feature technical design and adaptability make it a promising solution for the mitigating flood risk. With further refinement, this tool has a potential to become an indispensable source for disaster management, helping safeguard lives and communities against the growing threat of the floods. Overall, this mini project is a success. That's all from us. Thank you for watching.